Assalamu alaikum. Welcome to Sterling Learning, where education gets meaning. My name is Zubair Rasheed. I'm an electrical telecom engineer, a graduate of NUST, and today we are back with our series of Physics 10th Numericals, and today I'm gonna solve the numericals of chapter number 15, Electromagnetism. As always, concepts and formulas before numericals. So there are chapter 15 is a small chapter. It has only 2-3 formulas and I think only five numericals, and those numericals are very tiny numericals, so we will do it as soon as possible and it will take lesser time than the other chapters. So I have decided to mix chapters number 16 and 17 alongside with it, because 16 and 17 has no numericals, but 16 has some and or gates. Chapter number 15, Electromagnetism. As always, concept and formulas before numericals, transformer turns and voltage relationship. Vs over Vp is equal to Ns over Np, where Vs is equal to is the secondary voltage, Vp is the primary voltage, Ns number of turns in secondary, Np is number of turns in primary. For ideal transformer, the whole power is primary. The whole power in primary is shifted to secondary, so we have PS power in primary is equal to PS, PP power in primary is equal to PS power in secondary. Power in primary is Vp Ip and power in secondary is Vs Is. So let's start with the numericals. 15.1. A transformer is needed to convert a mains 240 volt into 12 volt supply. If there are 2000 turns on primary coil, then find the number of turns on the secondary coil. We have our Vp, because 240 is to be converted to Vs 12 volt, to be converted to 12 volt, so Vs is 12 volt, and if there are 2000 turns in primary, Np is equal to 2000, then Ns we have to find. So with this we have we know the formula we discussed in previous. Vs over Vp is equal to Ns over Np. We know, so we have to calculate Ns. The Np will go to the other side. Ns is equal to Vs over Vp into Np. Vs is 12 over 240 into 2000, which is 24,000 on top and 240 on the bottom, so 240 is 1 and 100, so Ns comes out to be 100 tons. A step-up transformer, first was step-down transformer, now the step-up transformer has a turn ratio 1 to 100. Turn ratio 1 to 100. Step-up transformer. An alternating supply of 20 volt is connected across the primary coil, so Vp is equal to 20 volts. What is the secondary voltage? Vs is to be calculated. So Vs is equal to what? We know the formula very well. Vs over Vp equal to Ns over Np. The turn ratio is 1 to 100. Step up means primary is small. Np step up means Np is less than Ns, or Ns is greater than Np. Same thing. Both are the same things. Some people understand it well, some people understand this well. So 1 to 100 means 100 Ns equal to 100 and Np is equal to 1. So Vs is equal to 100 over 1 into Vp. 100 into Vp is the value of 20 volt. So Vs is 20,000 volts. That's the answer for 15.2. Now 15.3. A step down transformer has turn ratio step down. Transformer turn ratio 100 to 1, which means Np is greater than Ns. So Np is equal to 100 and Ns equal to 1. An AC voltage of amplitude 770 volt is applied. Vp 170 volts to the primary if the current of the primary is Ip is 1 ampere. What is the current in the secondary? Is is equal to calculated. So Ip is given, Vp is given, so we know the formula. Vs over Vp is equal to Ns over Np. Vs is to be calculated. Ns is 1, Np is 100. Np is 100, Ns is 1. So into Vp, Vp is 170 over 100 is equal to 1.7 volts. Vs voltage secondary is 1.7 volts. Now we have to calculate the Ip is given Is. So we know the powers for ideal transformer. Vp Ip Vs Is. Vp we know is 170 into Ip is 1 and Vs we know 1.7 and Is is to be calculated. So Is is equal to 170 over 1.7 milliamperes. So 170 into 1 milliamperes. Current is 1, not 1 ampere, it is 1 milliampere. So 170 into 10 power minus 3 over 1.7 amperes is, which comes out to be as is is equal to 0.1 ampere. 15.4. A transformer designed to convert the voltage from 240 volt AC mains to 12 volt has 4,000 turns on the primary coil. How many turns should be on the secondary coil? If transformer, the current would be flow through the primary coil when the current in secondary coil is 0.4. Simple thing. Vp 240 volts and Vs, which is required, is 12 volts. If Np is 2000 turns, then Ns is what? And if Is is 0.4 ampere, then Ip is equal to what? Very simple question. We know the formula. Vs over Vp is equal to Ns over Np. Ns is equal to Vs over Vp into Np. Twelve over 240 into 2000. 12 ones are 12 twos. It's not 2000, it's 4,000 tons. Yes, 4,000 tons. It is 4,000, and when you cut it, it comes at 200. So Ns becomes 200 tons. One answer is this, which was required, and second is Ip. So we know for ideal transformer, we have Vp-Ip is equal to Vs Is, and we need to find Ip. So Vs Is over Vp, which is equal to Vs 12 into 0.4 over Vp is 240. So Ip comes out to be 0.02 amperes. The last one of this chapter, and then there are no numericals of 16 and 17. We will just discuss those chapters a little bit, and then we will start our chapter number 18 in the next video. Power station generates 5,000 megawatt of electrical power. So power is 500 megawatt, which is fed to a transmission line. When current would flow in transmission line, if the input, what current would flow, I we need to find, and V is 250 kilo volt. So we know the power formula when voltage and current is discussed, which is P is equal to VI. So we need to find I. So P over V. 5,000 mega is 10 power 6. 500 10 power 6, and 250 into 10 power 3. 252s out of 500. So 2 into 10 power 6 minus 3. It is I. 2 into 10 power 3 amperes. this is the answer of our 15.5 numerical. So now we are done with our 15 chapter. So I'm going to write little bit details of our chapter number 16. The name of chapter number 16 is Basic Electronics. Okay. In this chapter there is no numerical. You should say that proper numerical is none, but there are two conceptual questions that I have decided to include in my numerical lessons. So one is 16.7, conceptual question on details of all AND gates and OR gates would be discussed in the theory lectures, and if you would like to know about those, you should see my theory lectures. But few things that I would like to give here is the AND gate and OR gate. Two things I will briefly discuss here. One is AND gate. 1.0 is equal to 0, and it's little table. I will make a table. 1 0 is 0, A, B, and answer. Okay, 1 1 is 1, 0 1 is 0, and 0 0 is 0. This is the AND gate, and one is OR gate. A or B, B is this, A 1 0 1 0 1 1 1 1 1 0 0 0. This is the AND gate, this is the OR gate. Now about the conceptual question 16.7, show that the circuit given below acts as OR gate. This circuit is given. This is NOR gate. OR gate is not here, made not here. So this is the inputs A and B. These are the inputs, and this is another NOT gate, and output is Y. So we can do it by simply drawing the truth table. This is called the truth table. We're going to draw the truth table for this as well. Not so good drawing, but it would suffice the need, because you should understand what is the concept behind A dot A plus B plus is for OR, dot is for AND operations. A plus B bar, A plus B, first we will calculate A plus B bar, which is a NOR gate. A plus B bar, and NOT gate is simple bar. So A plus B bar and bar will give 1 0 0 1 1 1 0 0. So 1 0, A plus B, A or B, 1 and bar 0 0 1 1 but barred, so 0 0 1 1 1 1, but it is not, it has been not, so the not gate is the output changes, which is if not gate is fed 1, output is 0. 1 is input for not gate, output is 0. So 0 0 a plus b 0, if it is 1, it becomes 1, and then this whole value is barred 0, it will become 1 0 1 0 1 and 1 0. So this is what a simple OR gate. Output of this is equal to simple OR gate. So our question is solved. There is another conceptual question, 16.8. We are going to solve it as well. So A B A bar B bar A bar nor B bar. So this would be the answer here. A B A naught B naught A bar plus B bar whole bar. This is NOR gate. Not gate, simple values 1 0 0 1 0 0 1 1. So 1 0, A is not is 0 1 1 0, and B is not is 1 0 1 0. So A bar B bar plus 0 0 0 1. The result of this is same as AND gate truth table. This is called truth table. Okay, now we have done the 16. 17 is all about, this is all about information and technology. It contains everything from your simple telephone to today's smartphones, mobiles, internet, radios, computers, screens, laptops. If you are trying to be a telecom engineer like me, or electrical engineer, electronics engineer, because all those topics or chapters are topics are included in this chapter. You will have a pretty good or basic understanding of what you are going to study and what's it's gonna be to be like a telecom engineer or an electrical engineer or a electronics engineer. for that matter. If you are going to be an civil engineer or some other field, then you may not go deep in this chapter, but for the sake of MCQs and a little bit short questions, maybe uh, you should study this chapter as well. So in this is the end of today's lecture. That's all for now, and Allah Hafiz.